Hello everybody! In this video we are going to talk about the coordinate plane, sometimes referred to as the Cartesian plane. And when you call it the Cartesian plane, you are naming it after the person who created it, French philosopher and mathematician René Descartes. And he is famous for saying the phrase, "I think, therefore I am," and also super famous in mathematics for the creation of the coordinate plane. Because before Descartes, when you studied geometric figures or lines or anything like that, you had to construct them using straight edges and compasses, and you really couldn't do things like that, well, as we know, algebraically. So his creation of the coordinate plane was actually very revolutionary to mathematics. Now, we take it for granted because you see them all the time, but back in the day, that was a big deal. And the big deal was a coordinate plane allows us to define points as a set of ordered pairs. And when you do that, it turns out that you can describe lines by equations, you can describe circles by equations, so that you don't have to actually physically construct these things, you can just talk about them in a very general sense. So here is what a coordinate plane looks like. And I've made it all fancy, using what is called a foldable. All right, so this is an example in here of a coordinate plane. We have grids, yes. It is made up of a set of scaled perpendicular axes. And perpendicular means they intersect at right angles. And scales mean that I just have little tick marks on here that are equally spaced, that are worth the same amount. Like I can make each of these tick marks count as 1 or 2 or 3 or whatever. That's what it means to be a scaled set of axes. The horizontal axis is called the x-axis. That is where you plot the independent variables, values. The vertical axis is called the y-axis, and you will plot the dependent values there. And so some point A is defined by having an ordered pair. Its location is defined by having an ordered pair, x comma y, where the first number tells you where to travel horizontally and the second number tells you where to travel vertically. Point A is going to have a negative x value and a negative y value. What those are, of course, depends on my scale. If I were to count by ones, then it would be at negative 1, 2, 3, 4 on the x and negative 2 on the y. But I don't have a scale on there, so you can't say that definitively, because these x values could be counting by 5s, and those y values can be counting by like 1,000 or something, which is why the scale is important. Actually, it's the number one most important thing. Now, the point where these two axes intersect is called the origin, and it's just that point right there. It's where they hit each other, and it has coordinates 0, 0. Okay? Now, if you'll notice, up this way, we have all of our positive y values. Down here, we have all of our negative y values. Over on this side, we have our positive x values, and over here we have our negative y values. And so if I wanted to know what kind of points are available in each of these sections, in this first section of the graph up here, I have positive x and positive y's. Positive, positive. Okay. This second section of the graph here, I have negative x values over here in the negative and positive y's. This third section of the graph, I have negative x's and negative y's. And in this last section over here, I have positive x's and negative y's. And these four sections are called quadrants, and they are very important, and they are numbered. The positive quadrant is labeled quadrant 1, because when you study things in the real world, most likely the independent and dependent values are positive. So this is number 1 quadrant. And then you kind of want to go clockwise, but mathematicians had to make things complicated. So actually quadrant 2 is the one over here, where the x values are negative and the y values are positive. So it's going to end up going counterclockwise. So the negative quadrant is quadrant 3, and this last quadrant is quadrant 4. So those are the 4 quadrants, and you are required to know which quadrant is which. So now you don't have to make this cute little foldable that I did. All you need to really have in your notes is a copy of, or a sketch of, the coordinate axis for x and y, and then the origin labeled, and then if the point values labeled, like positive, positive, negative, positive, negative, negative, positive, negative, and then the 4 quadrants. 1, 2, 3, 4. And if you need more than one drawing, that's fine. They're your notes, but you have to know what kind of points live in each quadrant and what each of the quadrants are. One thing you have to realize is that points will lie either on an axis or in a quadrant, not both. Okay, you can't be in an axis and a quadrant at the same time. So if I give you an ordered pair and ask you, hey, where does that point live? You're either going to tell me on the axis or on a quadrant. Finally, for the review of coordinate graphing, we're going to talk about something that is going to be incredibly important all throughout our study of algebra, and those are called intercepts. And an x-intercept is the point where a graph hits the x-axis. And when I say hits, it could mean it just crosses right through it, or it could just like hit it and bounce back. So it intersects the x-axis in some way at the x-intercept. And then the y-intercept is a point on the graph where the graph hits the y-axis. Okay, and I have an example here of a graph. This happens to be the graph of an absolute value function. This point right here, that is the y-intercept. And this point here, that is the x-intercept. And what you have to know about intercepts is that one of their values in their coordinates is going to be 0. So at the x-intercept, you have some x value and a 0 y value. So y equals 0 at the x-intercept, okay? Because you don't have to move up or down, you just kind of go across, right? And so then at the y-intercept, you have 0 comma y, because x is going to equal 0. You don't want to go left or right on your y-intercept, you just want to go up or down. And so if I look at the coordinates of this graph's y-intercept, it hits when x is 0 and y is 2. And at this x-intercept here, it hits when x is 2 and y is 0. And these 2 points, the x-intercept and the y-intercept, become very, very important later on. So I need to make sure that you know how to find an x and a y-intercept.